Alright, talking about reducing radicals day number 2. Okay, so we have two different methods, if it's perfect squares or if we just have to factor using prime factors. If it's perfect squares, it's nice and easy. So if I'm looking at like the square root of 40, okay, I notice that the square root of 40, well 40 has factors of 4 and 10. Okay, well I'm going to use the factor of 4 because 4 is a perfect square, right? 4 breaks down into 2 and 2. The square root of 4 is 2. So I'm using 4 as a factor because 4 is a perfect square. 4 breaks down into 2 and 2, so the square root of 4 is 2. So we have 2 square roots of 10. The square root of 40 is equal to 2 square roots of 10. Same thing for number 2. This 63 has factors that are 9 and 7. Well, I'm using 9 because 9 is a perfect square. The square root of 9 is 3, so this becomes 3 square roots of 7. Now, if I don't, looking over here at my prime factor tree, 56 factors of 56 are 8 and 7. Okay, well none of those are a perfect square. Okay, so I'm going to break 8 down even farther. 8 breaks down into 4 and 2. Now, 4 is a perfect square, right? 4 breaks down into 2 and 2. Once we have a pair, the pair is going to come outside the radical and become one number. So that pair came outside, it became one number. Underneath the radical, I've still got the 7, I've still got the 2. So I've got 2 square roots of 14. Same thing for 27. 27 breaks down into 9 and 3. I'm using 9. 9 breaks down into 3 and 3. So again, once you have a pair, it comes outside the radical and becomes one number outside. Underneath, we've still got that Lone Ranger right there. Alright, so let's look at some examples on the back. The square root of 20. 20 is going to break down into 2 and 10. Okay, again, no perfect square, so we keep going. Breaks down into 2 and 5. Once we have a pair, I'm going to circle it. It's going to come outside. It's going to become one couple outside. So outside we've got 2. Underneath the radical we've got the square root of 5. Here we got, this breaks down into 15 and 3. 15 breaks down into 5 and 3, so we've got a pair of 3s. Again, once we have a pair, they come outside the house. They become one couple outside, so it becomes a 3 outside. Underneath, I've still got that 5 right there, so 3 square roots of 5. Square root of 216. Okay, if you don't know factors, right, so 216 is a big number, right, so I don't know the factors of 216, but I know 216 is positive, so I can always start with a 2. Sorry, I know it's even, excuse me, so I can always start with a 2. So that can break down into 2 and 108. Now again, I don't know factors of 108, but I know 108 is even, so 108 is going to be divisible by 2. Right, so now I have a pair of 2's. That's going to come outside the radical. 54, well I'm not done breaking down 54. It's not all the way prime yet. Okay, 54 is going to break down into 2 and 27. Alright, now I can break down 27. 27 breaks down into 3 and 9. 9 breaks down into 3 and 3. Now, I'm done factoring this because all of these numbers are prime. So now let's see what couples we have. Right, those 2, they come outside, it becomes a 2 outside. These 3's come outside, it becomes a 3 outside. This is still underneath the radical, this is still underneath the radical. So I've got 6 underneath the radical, 2 times 3 is 6. Outside the radical, I've got a 2 and I've got a 3. Now outside, we're going to multiply those two numbers together, so that's going to give me 6 square roots of 6. Alright, let's look at 98. 98 breaks down into 2 and 49. Oh my goodness, perfect. 49 is a perfect square, 7 and 7. That comes outside, we've got 7 square roots of 2. $320 breaks down into 32 and 10. Alright, so 32 breaks down into 4 and 8. 10 breaks down into 2 and 5. 8 breaks down into 4 and 2. So let's look at some factors. So we have some pairs here. We have a pair here. So outside comes 4. Outside comes 2. Underneath the radical is still that 5 right there. So we've got 8. Looking at the square root of 112. 112 breaks down into 56 and 2. 56 breaks down into 28 and 2. so we know we got a pair of 2's. Break down 28. 28 breaks down into 7 and 4. And 4 breaks down into 2 and 2. So we brought a 2 outside, another 2 outside, so we have 4 outside. We have this 7 underneath the radical. Oh, sorry, 7 underneath the radical. Square root of 180, okay, looking at factors of 180, 18 and 10. That breaks down into 2 and 5. This breaks down into 9 and 2. We know we had a pair of 2's. All right, 9 breaks down into 3 and 3. Pair of 3's. So outside we've got a 3, we've got a 2. Inside we've got square root of 5. So again, outside the radical we multiply. 3 times 2 is 6. Underneath the radical we've got square root of 5. Same thing here with 80, 8 and 10. 2 and 5. 4 and 2. We know 4 is a perfect square. 2. We know these pairs come outside. Another 2. Underneath we've got 5. So this becomes 4 square roots of 5. Now, okay, that's fine. We can keep going. All right, so 288. Again, I don't know factors of 288, but I know that I can divide it by 2. So 144 and 2. Now 144 is a perfect square. It's 12 and 12. 12 square roots of 2. 62. Looking for factors of 62. We know it's even. Okay, so we've got 31 and 2. 31 is a prime factor. 2 is a prime factor. So you can't break it down any farther. So my answer is the square root of 62. It doesn't reduce. 48. Okay, we can go 24 and 2. 24 can be 12 and 2. So we know we've got a pair of 2's. That's coming outside the radical. This 12 breaks down into 3 and 4. And the 4 breaks down into 2 and 2. So another pair of 2's comes outside. So outside we've got 2 and another 2. So outside we've got 4. Underneath we've got that square root of 3, so 4 square roots of 3. And lastly, 12 breaks down into 6 and 2, 2 and 3, so 2 square roots of 3. Now, challenge, what do you think you would use in method 1 instead of perfect squares to simplify cube roots? So instead of perfect squares, we're looking for perfect cubes. Now, what does that mean? A square root is raised to the 1/2 power. A square root is raised to the 1/2 power. Okay, that's why we're looking for pairs, because we need a pair to make it 1/2 power. So a cube root, looking at number 13, see this 3 right here? Instead of needing 2, like we did here, we needed a pair of 2's. When we had a pair, it came outside and became one number. Now I need 3 of a kind. So a cube root is looking for 3 of a kind. That's what that 3 means right there. A cube root is raised to the 1/3 power. Raised to the 1/3 power. Alright, so now you're looking for 3 of the same number. Still doing it the same way. I'm still going to break this down into its prime factors. So 64 breaks down into 6 and 4. 6 breaks down into 3 and 2. And 4 breaks down into 2 and 2. So now I know I have all primes here. So I've prime factored it. Now I'm looking for 3, right? Because we're looking for the cube root. So 3, now it comes outside and becomes one number outside. So 2. Underneath my cube root, I've still got that 3 right there. So 2 cube roots of 3. Same thing with 54. Okay, I'm looking to factor it into its prime factors. So 2 and 27. 27 breaks down to 3 and 9. 9 breaks down to 3 and 3. So those are all prime numbers, so I have factored it completely. So now we're looking for 3. Again, this is the cube root, not a square root. The cube root, so I'm looking for 3 of the same number right there. It's going to come outside of my cube root. So it's going to become one number outside my cube root. And I still have this 2 inside of my cube root.